Okay, so welcome again for Cloud Collective. This is, I think, our fourth meetup in the last 7, 8 weeks or so. We have been trying to do once every 2 weeks now. So I'm Praveen Salitra, Cloud Architect and Director of Technology here at Egen. We have been here for almost now 8.5 years. Started as a software engineer, but then over the years have grown into some sort of building and leading this organization from technical perspective. And who is Egen? So we are a cloud native data engineering firm here in Chicagoland. So we are a little bit of southwest of Chicago, one of the suburb called Naperville. But most of our clients, most of our customers are from Chicago. So we are very proud to be from that community. And I would say 6 years ago or so, we started working with some of the startups at that point in Chicagoland, and who eventually became some of the largest unicorn from Midwest, fastest unicorns in United States, highest valued healthcare private company right now in US and things like that. So yeah, that's our clientele list. And in the last couple of years, we have started working with some enterprises as well, helping them, of course, helping them in modernization, which means either we are helping them refactoring, re-architecting, or in few cases helping them move from on-prem to cloud as well. Not too much in the lift and shift operations, mostly in replatforming and re-architecting as well. So that's all about Egen. As I said, we started with industrial IoT 6 years ago, working with one of the largest OEM in the world. So all of our learning on event-driven architecture, modern data pipelines, some of the newer concepts of how to deliver applications, right, using microservices or serverless ideas. We have been playing with it. We have been working with containers, streaming pipelines for almost 6 years now. And then in the last 6 years, we have grown into healthcare, retail, mostly in the last couple of years, fintech in the last 6 months or so. We have been growing and then acquiring customers, but then also building internal platforms as well at this point. So, and that's what it actually shows up in our technology stack, is that most of our team members these days are using, experimenting, learning, and then of course working with the customers, trying to solve their problems with whatever fits or whatever works for that particular problem set. And the whole idea about meetup here as well is just to distribute all that learning. Sometimes those are coming from our own experiments. For example, the topic for today, or in some cases, some topics are coming from our deep expertise working with that technology stack for the last 4, 5, 6 years or so. And then we are just putting it out in the public at this point. So we have always been on hiring. So if you are interested in any sort of role, we have majority of the roles open in engineering and product at this point. So head over to egen.solutions/careers. These are all based here in Naperville at this point. So let me introduce today. The topic is Multi Cloud MLOps with Kubeflow. And then it will be presented by our senior software engineer, Junaid. He has, I think, joined us a year and a half ago, probably. And then quickly started showing up a lot of interest in ML. On his day job, of course, in his project work, he is probably not using these things at this point. Mostly, he is leading our Android team on one of our customer project. But then he has been experimenting and working on the side on exploring what's going on in ML operations, right? How do we simplify and automate those workflow pipelines? And one of the things, especially with Kubernetes being under the hood across most of our projects, it felt to all of us, it felt kind of interesting that okay, there is a product which can allow us to run automated ML workflows across the cloud, because behind the scene or below the belt, it's actually Kubernetes, right? So that's the topic for today, and I will hand it off to Junaid. So let's go from there.
Thank you, Praveen. Everyone.
Yep, we can
Let
hear
me
you.
just, I guess you guys are able to see my screen, right?
Yes.
Oh, yeah. Thank you, Praveen. Yeah, let's start with the ML workload before, talking about the Kubeflow and all. So as we are all aware that in machine learning, which is kind of like a subfield of AI platform, we usually try to ingest data to any of the machine learning algorithms and do the training and all these stuff, which includes a lot of stack. right? In any of the ML workflow, we usually encounters these steps all in our daily life. And those steps are kind of like the initial step would be to gather and refine the data, do some analysis on top of it, see if the data has or contains some errors or not, do some sort of like validation. Once if we are done with the data part, doing the cleaning, transformation, all this stuff, we then provide this data to train the algorithms. And we have a lot of algorithms. The scikit-learn library provides algorithms. Similarly, we have a lot of algorithms in TensorFlow and Keras libraries tools. These tools, they do provide a lot of algorithms to train these specific algorithms. Yeah. So right after the once we are done with the training part, we usually save those models for the later use, like use those models into the production environment. And right after that, the last step would be to monitor whatever that we are doing. So of course, all in all, this is a recursive process. Whatever we are trying to predict in the production environment, later on, we might be reusing it in the later use case scenarios as well. So all in all, ML workflows comprises of all of these steps. Some of them can be reusable, some of them can be repeatable as well, but others they cannot. Like training the algorithms, we might train one algorithm with a couple of parameters, and those parameters would not work in some sort of like different data sets. So it all depends on the business case scenario that we're working on and the thing which we're working on. Um, Moving onwards, then definitely, yeah. While working on these stuff, the data scientists or researchers, they usually perform those steps, usually maybe in their laptops. Sometimes if they require some sort of like computational powers, they have this flexibility to access those training rigs. And sometimes they do usually uses this cloud providers for a couple of things. But all in all, for the deployment, it usually depends how the organization architecture is laid out. So onwards, yeah, regarding the ML workflow. So uh, on top of it, the pipeline, if we talk about the pipelines, these are kind of like to simply pack together all of those reusable components in a single workflow and create a pipeline on top of it, which can be reusable and which perform or which gives the best results on top of it. And the benefit of using those pipelines are numerous. Definitely, the first of all, the flexibility that we have. Definitely, whatever the components that we are using in any of the ML workflow, we can use in n number of workflows. Apart from that, then definitely we can achieve scalability. We can reuse the same component. We can deploy those same components on two or three or different number of pods, depending upon the computational power and resources that we need and require for the specific training. So all in all, these are some of the benefits of using pipeline. The challenges could be how we are getting the data, and definitely this could be tough depending upon the nature of the problem that we are trying to solve. And data integrity is also the next big challenge in this field as well. So apart from that, yeah, we have those flexibility, extensibility, and scalability while using this machine learning pipelines. Um, so again, the same diagram. Yep. We might have different workflows and environments and setups for different sort of environments. So say if I'm using my own laptop as a data scientist or researchers, I might be using some sort of like laptop, or depends upon the computational resources and the model that I'm training. I might be using laptop or maybe cloud. So it all depends upon the scenario and use case scenarios that we encounter. Moving onward, so Kubeflow, yeah, as we are aware of the Kubernetes, which is a kind of like open source orchestration, container orchestration platform, and it helps us to automate a lot of stuff related to the deployment, scalability, and things like that. So Kubeflow actually runs on top of Kubernetes, and it usually provides all of the flavors that Kubernetes provides, like scalability and then rollouts mechanism and a lot of different things that we can achieve with the help of Kubeflow. All in all, Kubeflow provides a scalable or portable and distributed sort of ML workflow that we can achieve with the help of Kubeflow. Moving onwards. Yep, as discussed, it runs on top of Kubernetes. And as we are aware of the Kubernetes, it is sort of like open source system for automating the deployment, scaling, and management of the containerized-based applications. And Kubeflow actually it uses all of those resources of the Kubernetes. I'm going to be explaining a lot of them in the next couple of slides. So please bear with me. Yeah, so these are some of the components in the Kubeflow. Definitely provides the central dashboard. I'm going to be showing that central dashboard in the demo as well. And through the central dashboard, we can access a lot of different features that Kubeflow provides. We can instantiate this notebook servers. We can run whatever the experiments that we want to perform on the cloud on that specific notebook servers. And then we can trigger the Kubeflow pipeline jobs by using those notebook servers. Definitely, we can provide and describe the metadata for each of the component. And I guess many of you might be aware of the Istio service. So Kubeflow does uses Istio service. It cannot reside outside this Istio service. So in order to use Kubeflow, definitely the Istio should be there in the cluster. For some of you folks who don't know the Istio is like it provides the service mesh specialty. Um, so let's say in any of the modern architecture, we have a lot of different microservices, right? And in order to communicate and in order to traverse the network or in order to communicate between these different microservices, uh, there are a lot of things underneath behind it that we have to configure, like service discovery, load balancer, doing the authentication, and all these stuff. So Istio is a sort of platform or service which provides all of these facilities to us, and it takes care of everything regarding the communication, how we're going to be communicating with the microservices, how one microservices will communicate to another, and things like that. So Kubeflow does uses Istio to manage its services. Um, and on top of it, we have this KF serving. KF serving is also a very good approach and a good feature that Kubeflow is providing. Um, it is like it provides pluggable servers which provides or which has those TensorFlow and Keras models already in. All we're going to have to do is just provide the link or the path of our trained models, and the KF serving component will definitely sort it out by itself that how it's going to run that specific model. And definitely we can configure whatever the cluster requirements that we going to be providing it. We can define it in KF serving as well. And then we have KF fairing and Khatib as well. I'm going to be explaining that in the demo as well. Khatib is a more user-friendly approach of creating the pipelines in Kubeflow. This is more kind of like helpful for the end developers or maybe the data scientists who are kind of like working on those uh, models and doing the training, all this stuff. And this is kind of like helpful for those who doesn't want to include themselves in the MLOps related sort of work. So yep. So this is the basic dashboard of Kubeflow. Um, we have a couple of different things in here, like we can see the pipelines, we can associate the Kubeflow servers, then Khatib, I will be explaining that. Then we can definitely store the artifacts and things like that. So I guess I've discussed a couple of things earlier at the start as well, but as you are aware that Kubeflow is running on top of Kubernetes, which means that we can run Kubeflow in any of the cloud provider like GCP, AWS, Azure. We can definitely run Kubeflow on premises and local system and local computer as well. So it depends totally how our architecture is laid out. We can also use it in hybrid environments as well. So, and these are some of the components that I've discussed as well. And some of them I'm going to be explaining on later onwards as well. So this is the deployment procedure that we usually follow. If definitely if you have a single node deployment, definitely you can go ahead with the, if you are limited to a single node cluster, then definitely you can go for single node deployment. If you want to experiment, like say sometimes you need the computational resources in order to perform some certain actions or do some deep neural network computation. So in that scenario, definitely you can run a specific resource on any of the cloud specific provider. You can deploy the Kubeflow in the cloud deployment environment. You can tear down once you are done. If you want it in on-premises, definitely you can go ahead and install K8's deployment and Minikube deployment as well. So these are a couple of options that we have when installing the Kubeflow. Next, yeah, these are a couple of sorry, this is a short glimpse related to the pipelines. A pipeline, we usually define small components, reusable components, and then we can pack them together. We can define the dependencies, which component has a dependency on which component, and then we can link them all together and we can perform those computation in a single pipeline. Each component is kind of like a self-containerized Docker image, which we can create with the help of Python SDKs that Kubeflow provides. I will be explaining that later on as well. And those Docker images can scale in and scale out as well. We can define the um, ins and outs of specific containers on while defining the pipeline. And yeah, this is how the pipeline looks like. Onwards, so a couple of different frameworks. We do have this facility to use those specific frameworks. Some of them is MPI training, Apache MXNet, stable release. Apache MXNet has the stable release in March 2021. PyTorch training, MPI training in Apache MXNet, they are all in alpha release in Kubeflow. The stable release are for Volcano Scheduler, Gantt Scheduler, Job Scheduler, and TensorFlow training job. So as we are all aware of the TensorFlow training job, the Kubeflow does provide this feature in on top of Kubernetes as well. And as we are aware that TensorFlow does provide us this flexibility to train our algorithms distributedly in a number of pods or in a number of computers or in a number of containers. So definitely we can avail that specific feature and we can reuse the same thing in on top of Kubernetes with the help of Kubeflow by using TensorFlow for the TF job. Um, yeah, so this slide shows how we can define the pipeline. How we can define the pipeline with the help of SDK. So usually Kubeflow provide the Python SDK where we can define our pipelines. So the compiler, KFP.compiler, which means Kubeflow compiler, it compiles our whole Python code into a single YAML configuration file. That YAML configuration file, later on, we can re-import it in any of the cluster, regardless of the cloud provider. So then we have this KFP components. The KFP components is used to wrap up your Python function into a Dockerized based container image. There are a couple of different ways to do it. Like if we want to go ahead and use the function and convert the function to a containerized based application, then definitely we have that specific feature of functionality to do it as well. Call function to container op. This function will help us to do that. Then we have this kfp.components, load component of from file. If we have some component inside a file or method, we can use this specific method. Definitely then if you want to load anything from the URL, you can go ahead and do it. This kfp.dsl, this is the main thing where we usually define all of the things inside our pipelines. So we can define the components, we can define the pipelines, the parameters, the ins and out, the dependencies, and also the volumes that each specific Docker container is going to be using. Um, Then we have this KFP.client. The KFP.client, usually if we want to run a specific pipeline from the same Jupyter notebook, if that is the case, then we can use this KFP.client function, which would help us to run that specific pipeline on a specific Kubernetes cluster that we want to use. All we're going to have to do is just provide the endpoint to that specific client. The right side of the image, yep, the right side of the image, it shows how we can achieve the same thing, which I've discussed earlier. If you have a specific uh, function called myappcode.py, in order to containerize it, all you have to do is just annotate it with kfp.dsl.component or kfp.dsl.containerop. It's going to automatically wrap this function or Python function into a Docker container image. Then we can define the pipelines. So say you have 10 different components, definitely you're going to have to tell the pipeline that which components or which container would run first, then which container would run after each other. So in order to sort or define that sort of dependencies, you can define that specific thing inside the pipeline or dsl.pipeline. And then again, yeah, you can generate the YAML in a zip file, and then you can rerun the same pipeline in any of the cloud provider I discussed. Moving onwards to the demo, let me show you the demo, guys. So yeah, so before running the pipeline, let me explain a couple of different files right here. So I have these different Python files. I have the pre-processing folder, and inside the pre-processing folder, I have this Docker file and the Python file called preprocessing.py. What I'm doing right here is I have this method preprocessed data. I'm loading the data from one of the data set that skitlearn or scikit-learn provides. I'm loading the Boston data set, and I'm extracting or splitting the data into training and test data sets. And then I'm saving those in this format in a file called xtrain.npy with the help of an NP function. And that is the whole purpose of this specific Python function. Then I have this Docker file, which would run this specific application by using Python 3.7, and then it's gonna install the scikit-learn and numpy. On top of it, it's gonna copy that specific file into whatever the working directory that we have defined, and then it's gonna run this specific Python file. Then we have the training Python file. Whatever the training data that we are getting, first of all, with the help of parser, I am extracting the training data and labels of it, and then I'm passing that specific data to a training model. And then I'm doing the specific training with the help of a regressor model that I'm using in here. And right after, when I'm done with the training part, I'm saving that data or specific model with the help of joblib. And the name of that specific model is model.py. Then in the test.py, again, I'm doing the same thing. I'm extracting the test and train data and whatever the model name. So previously I've used the model or saved the model with the name model.pky. So this is where I will be getting the model name, and I will load the model from the joblib again, and I will do the prediction on top of it. So all of these Python files has their separate Docker containers, and the whole purpose of Docker files, and the whole purpose of those Docker files is to run those specific Python files. And then at the end, let's move in here. So yeah, so as you can see here, for the processes of, I'm using this specific image. So before that, uh, I've created those Docker containers for each of those Python files, and I have uploaded it into my own repository. originate 55 Kubeflow, and you can see all of those containers right here, right? And then I'm using those images inside in here for the preprocess image I'm using right here, and I'm telling that what it's gonna be generating at the output. So at the output, we are seeing that we have those four files that this specific um, container or this specific component is gonna be producing. Similarly, for the train of arguments is gonna be the training and the test data. Similarly, right here the model name, and this is just for the deployment once we're done with all of the stuff. So this is where we are kind of like defining the pipeline. First of all, I've instantiate this process underscore op, and this is just the name and the description of the pipeline. And right here, once this process will be completed, I'm extracting the data from this component and chaining that inside this specific component, which is process underscore op outputs of the training data. And I'm also telling that this step should run right after this step. Similarly, there's a test operation, and right in here, whatever the steps that I'm getting uh, from here. So this steps produces four output files. Two of them are related to the training data, two of them are related to the test data. And the test data I'm using it right here. And similarly, whatever the data that I'm getting, so from here in this component, I'm getting the model name, and this is where I'm using the model name, and I'm also telling that this should run right after this step. And this step is to deploy that specific model with the input arguments uh, like this. And then later on, with the help of this kfp.client, I'm telling the host URL where my cluster resides, and please run this specific cluster. So now let's run this specific cluster. You can see the experimental details. There are details as well. Yeah. So this is gonna produce a simple graph with each step that we are trying to achieve. Similarly, if we click on any of the component, we can see its inputs, outputs, we can see its logs, we can see the pods data, the volumes, the metadata that in case if we are planning to use, and the logs of it as well. So, yep, this is how we can achieve and run a specific pipeline in Kubeflow. So now, moving back, okay. So yeah, so right now, as we have seen that the way how we proceed and how we define the pipeline is a more sort of like a DevOps way of defining the pipelines. So most of the time, usually the data scientists, they are not familiar of all of these stuff and technologies. So what Kale is doing is Kale is kind of like bridging the gap by providing a simple UI through which we can directly deploy our pipelines with the help of Jupyter Lab interface. That's it. So the data scientist doesn't have to do anything. They don't have to worry about how we're gonna be containerizing the things and things like that. So, and the idea was to allow ML practitioners to focus on their code while still being able to make use of the Kubeflow pipelines. So, yeah. So this is how I will also show you the demo as well. So in the Jupyter notebook, we can define each and every step. We can define whether if we're going to be using it inside our pipelines or not. And we can define similarly in the same way, the way we define the dependencies and the steps, we can define those inside the Jupyter notebook lab as well. So let me just quickly show you. You guys see my screen? So I have, first of all, a very basic example on Titanic data set. We are seeing how many of them in the Titanic crash accident got survived. So with the Kale deployment, so first of all, let me explain this. So inside these each block, we can click on edit and we can define the steps of the specific pipeline. So for now, this is just the import. So I've defined that as import. Similarly, this step is to load the data, the pipeline step. This is one of the step in the pipeline. So we can define it as a pipeline step, the step name. We can skip those blocks which would not be useful in the pipeline. So say if you are doing some exploratory data analysis, definitely you can skip those part and you can only include those part which are kind of like necessary to your pipeline. So say this one, we are trying to play with the data and this is kind of like a data pre-processing step. So we also define that this is one of the step in the pipelines. We can also define that whether if we would require any sort of like GPU resource for this step or not. It totally depends on the requirement at the end. Then this step is the feature engineering step, where we are kind of like creating new features by looking into the data set and things like that. And right in here, we have defined that this step is usually depends on the data processing step, which is the previous step. So this component or this block will not run until this block gets finished. Um, so yeah, similarly, for each step, we can define the dependencies, the step name, the pipeline step. Similarly, we can skip the pipeline as well. Similarly, we can play with the matrices. Say if you want at the end, if you want to see the matrices um, of any algorithms, then definitely you can go ahead type this specific cell type. Um, so yeah, the rest is the same. And then we can simply go ahead, press this compile and run. All of a sudden, I see some sort of like errors. So as you can see right here, this is the basic web UI where we can see all of the functions right here. We can see the pipelines that we have run previously. So I was playing with all of these pipelines, the dog breed, ML Titanic. You want to see the graph of it. So this is how the graph looks. Similarly, this one is on the Titanic. So the experiment part is where we usually perform the hyperparameter tunings. So the Kubeflow and Khatib does provide this feature to perform this hyperparameter tuning and optimization. So with the help of this, we can define a lot of parameters and we can run our specific algorithms by looking for the best hyperparameters for our algorithms. Maybe because of for some reason it's giving me an error. I have to check the logs and see.
It's not a valid pipeline name.
Yep, correct. Thank you. Since this is running, let me explain this hyperparameter tuning with Khatib as well.
Is your system now struggling with the network, or is it with running? Or probably did we put a small node there wherever the Kubeflow is running?
I guess it was running just like half an hour before. For some reason, this error might be because of
I think the previous error said
connectivity.
the experiment name was wrong or something like that. Let's see. I think yeah, suddenly all is so slow.
So yep, I guess I might have to create a new experiment for each and every run. So yeah, so this is how we can achieve the same pipeline stuff with the help of just using the Jupyter notebook. Um, so while this is running, let me explain another feature on top of it, which is related to the hyperparameter tuning. Onwards, let me just open up another example that is related to dog breed classification. So with the help of Kale, we can also perform the hyperparameter tuning as well. So what hyperparameter tuning, most of you guys would be aware of that we have to define some sort of like uh, uh, learning rates and to define, I mean like we have to define some sort of like learning rate in our algorithms to do this sort of like iterative process. So for each step, with the help of these parameters, what it usually do, it tries to use or it tries to search those parameters which fits best uh, uh, inside the algorithms by checking the accuracy as well as by um, checking the errors using those specific parameters. And those number of nodes are kind of like the nodes that we define, the deep neural layers that we usually define inside our algorithms. And the method we can define grid search or any other searching algorithms that we're going to be using. So right now, this is what I've defined. Let me go ahead, create a new experiment. Read. At the same time, we can see right here um, each of the steps in a specific Kubeflow pipeline, how it is running. And similarly, if you want to see the output of a specific thing, you can see. So as you can imagine how useful this is, by means how useful is like how we can create the pipelines by just simply using the Jupyter notebook, which means that you don't have to worry about creating the whole pipeline by using Python SDK file until unless if you're going to prod. That is the other case scenario. But for the data scientists or for the end user who are kind of like working on training the models, then definitely this is a kind of like very useful step for them. And similarly, on top of it, they can perform the hyperparameter tuning as well to see what actually is happening. So the hyperparameter tuning part, it usually takes time. So let me show you the example which I ran before, the same thing, because it's an iterative process. So what the algorithm usually does is it iterates, it selects one parameter like running rate, sample size 2 or maybe 10 or maybe 256, depending upon the variable that we have given. And it selects the learning rate, and then it perform all of the computation on top of it and see whether how much is the accuracy and what we are achieving on top of it. So say for learning rate right now, it says we have achieved the best accuracy with the total number of nodes 768 and learning rate of 0.0001. And this is a kind of like a simple graph for that. You see this, we have achieved the highest accuracy somewhere right here. And for that, the total number of nodes is around like 600 or something. And similarly, the learning rate is around something close to 0.001. So this graph usually helps us to analyze that, okay, what are the other parameters doing and how well they are performing. So yeah, this is the overall working flow of the Kubeflow pipelines, the Cathib, and the features on top of it. So going back to the slides. So yep, I guess pretty much everything was clear. Do you have any questions on top of it?
Anyone? Any questions so far? I have one. Yeah, go ahead. I think someone also opened up the microphone.
This is Deepan here. I just wanted to take a moment to thank you for taking the time and sharing the knowledge. So that's what I wanted to express, to share
Thank you.
gratitude.
Thank you, Deepan. I hope this could really help you guys in the future or in your upcoming projects.
Cool, and thanks. Of course, every 2 weeks we'll have something fun or something learning for sure that we are trying to put it out. I think I have one question, and I
Sure.
see some of the folks who have used, let's say, SageMaker on AWS, right? Which also provides some of the capabilities. I don't know if it is a one-to-one mapping. So whoever has used SageMaker here and some references, whatever you got from here in Kubeflow, Any idea, any understanding? Of course, SageMaker is specific to AWS. Your Google has what, ML Studio or something like that, right? Or AI Studio, whatever they call it. Here we are talking about something that's gonna be multi-cloud. Kripanshu or Varun, who was using SageMaker? A little bit of here things here and there.
Yeah, I was using it.
Do you see some similarities from there to here with respect to integrations and then also ability to run Jupyter notebook integration and other pieces?
There is not much similarity, but yeah, like it's mainly like here, like we saw like how this whole thing like it goes into pipeline and everything. It's mainly there like how you use with the different services. Like for instance, like you can
AWS
include
services.
lambdas and stuff. So it's integrated within the services provided by AWS.
Yeah, makes sense, of course, and that's how they. I think 2 years ago and year ago as well in the reInvent in AWS, they are going all in with SageMaker, making it the single IDE for everything, and then dropping a lot of integrations, a lot of services every reInvent. Yeah, Junaid, you were saying something.
Yeah, so I'm not sure about the KF pairing and specifically this TF job as well, if the SageMaker is providing or not. But KF serving is a very good feature that Kubeflow is providing. So say you want to go ahead and you want to go for production, right? So in a real case scenario, definitely you might have to create Docker images for each of the component, right? But what KF serving provides is like they have their pre-built images for for this TensorFlow as well as on Keras, PyTorch, and things like that. So what you have to do is you just have to define the configuration and you just have to tell your model location. That's it. The rest of the stuff KF serving automatically handles, like either if it's a scaling one, if it's a rolling out to the production, like the Canary rollout and things like that, which is a very good feature which Kubeflow provides. I'm not sure whether SageMaker is providing this or not. On top of it, the TF job, I believe SageMaker does provide this TF job, but running TF job on top of Kubernetes is also a very challenging thing, and this is what they have actually achieved as well. And a lot of different folks, they when it's come to scaling, definitely they want something which runs on top of this Kubernetes, and while using this TensorFlow, which Kubeflow provides as a TF job, and which is also sort of like very huge achievement for that. Library, usually Google supports it, and
Yeah,
it uses the deep learning community for all of this stuff.
interesting.
One thing I would like to say, so I was in my previous company, we were trying to solve this problem where since we had legal data, we didn't want to give access to like production access to legal documents to data science team to store it on their machines and stuff, right? So this problem arises where how do you actually run the models without, having access to production system? So I was kind of in charge of setting up the pipelines, and one thing like which we were doing in Azure DevOps is it has very good integration with ML Studio, if I'm
Yeah.
not mistaken, or Azure ML. Yeah, and then so what you do is you can hook up pipelines through DevOps services as well, and you can trigger. Basically, you can set some parameters where there's like let's say accuracy or precision, like whatever parameters matter to you, and you can do conditional updation of model and then deployment of model in your releases, which was like a very cool feature for sure.
Yeah, no,
That is,
thanks for sharing. Of course, I mean, feel every cloud provider is going all in with their IDs for data science as well, right? Or this particular community here. This is ML Studio from. Now it's rebranded as Azure Machine Learning, looks like. But no, ML Studio is still a thing, right? As a name, I have seen that.
Yeah, they have two offerings. There is Azure Machine Learning. So if you go to the console, like their console, you will see like ML Studio, and you can also like
Okay.
provision Azure Machine Learning.
Cool. So that is there, and then of course on Google side, what is it? AI Studio? Studio?
With
They,
AI
oh,
Studio.
AI platform. They didn't want to put Studio or ML there, looks like. Yeah, similar idea there as well, looks like. Isn't Google's offering just based on Kubeflow? Isn't it?
Yep, I believe, yeah.
Right.
Yeah.
This is just using Kubeflow underneath or
Yeah.
something like that, right? I think I saw
Yes,
all those things.
that is correct. Yep.
Cool. Okay, any other questions? Perfect. Just a simple story. I think 6 years ago, when none of these tools were available or available from cloud or managed services at that point, right? And in one of our industrial IoT customer, we actually were working with data science team, and they were like, well, we need faster way of turning our models in working with live data, run through pilot mode, and once that is done, deploy them, see how it's working and things like that, right? I remember we had put a data engineering team with the data science team. In one entire quarter, they just did one model, and then in the next quarter, they did only two models. And then I think another team we put, we still have those engineers on the call, probably not today. But then we developed some sort of a automated uh, model pipeline orchestration or model orchestration with a UI and some things behind the scene as well that will pick up this model whenever the data science folks are going through the UI, entering some parameters, and then deploy it onto the cloud provider as well. So that was 6 years ago or 5 years ago actually. And if we are supposed to do today, there is no point of doing all that kind of custom work. Just utilize either the offering from the cloud provider or something like what we just saw. If you want to be multi-cloud and if you have multiple things to support or multiple clouds to support or maybe on-prem. So thanks, Junaid, for this pretty interesting topic today. Hopefully it was helpful to some of the folks or at least everyone on the call. And that's pretty much it for today. We don't have any next meetup announced. I'm working with the folks at this point. So either it will be announced next week or so, or we'll just take one extra week and then come back. So thanks everyone for joining today. Hope you have a good time and everyone be safe.